3 years later, here we are. Okay, so your table of contents is all updated. So we plan to have our test on Thursday. What day? Thursday. So that is on reflections, rotations, and translations. 3 things. Reflections, rotations, translations. This is a test, which means what?
No notes.
No retakes, no notes. So that means today is Monday, so you have a Monday and Tuesday and Wednesday to make sure you figure out, make sure you know what you're doing. So don't walk in Thursday and think and not know what you're doing then. Does that make sense? And I'll give you a practice test and videos. I'm going to sneeze. Ladies, I'm going to give you a practice test before, so that way you make sure that you know exactly what's on it. Okay? Okay, you got some colors? All right. Okay, this is reflections. Once again, reflections are rigid motions. Remember, rigid means that they are congruent. So they might be flipped backwards, though, because remember, when you reflect something, it is backwards on the other side, correct? Same distance away from the line of reflection, just backwards. Same size, shape, same length, same angle measure, same all of that. Okay, so you have this little picture. Do you see the line of reflection? I'll color it orange. This right here is a line of reflection. You might also hear line of symmetry. So if you see something about symmetry or a line of symmetry, that means the same thing. So line of reflection, line of symmetry, same thing. Now the most important part about this, and this is how we're going to use, make sure your laptop's away, we're not doing laptops right now. We're going to be using the idea of the fact that this is a perpendicular bisector. What does bisector mean again?
Breaking it into two.
Breaking into two what?
Equal pieces.
Equal pieces. So we're going to use the idea of bisector, because bisector means we have equal pieces, right? In this case, we have equal segments. So basically, the distance is going to be equal on both sides. So let's look at C. You see the distance from C to the line of reflection? Do you see how it's equal to from C prime to the line of reflection? So we're going to use that whole idea that everything's going to be the same distance away, which happens if there's a mirror. Because if I'm standing here and there's a mirror 2 feet in front of me, I will see myself 2 feet on the other side of the mirror, basically, in the mirror, correct? Because you see the same 2 feet of floor in front of me, and then I'll be on the other side, the exact same distance away. Okay? Let's review. Okay, one of you needs to move or piece your legs together. Let's review some algebra down here. Okay, so you might want to grab a colored pencil because this graph did not turn out super dark. Okay, so the first one we have is the x-axis. So where is the x-axis at? It is this one. Boing. That is the x-axis, correct? Now let's go down one. Because if I say x equals 4, that looks different. Do you see where x equals 4 is underneath it? It is over here at 4. And then just pause and look at those two. Because do you see why people make a mistake with this? Because when I say x-axis, I'm talking about horizontal, right? If I say x equals 4, I'm talking about vertical, right? Vertical at x equals 4. So you go on the x-axis to where 4 is, that's 4. And then you make a vertical line. So make sure these are straight in your brain. We know x-axis is this way, but x equals 4, or x equals 2, or x equals 7 is up and down. Very common mistake. And if you ever have Desmos, you can always type this in Desmos and you will remember that it is a vertical line. Okay, let's go to the next row over. We have y-axis. Where's the y-axis? That is going to be the vertical line, right? That's vertical. And there's a typo here because this, scribble this out right here. This is supposed to say y is -6. Y is -6. There's a typo there. It should say y is -6. If you look at the picture, it's clearly not at -3, it's at -6. Fix this typo right here. It's supposed to be y is -6. Okay, and so when I look at this, do you see how it is down here? So the graph y is -6 is going to be a horizontal line. It's going to be a horizontal line. You're going to go on the y-axis to -6 down here. This is all just algebra review. Good on those 4 picks? Okay, next over. We've got the line of y equals x. This has a positive slope, so it is uphill. And it is the perfect uphill of rise 1, run 1, rise 1, run 1. So this is a rise 1, run 1. Rise 1, run 1. So basically, starting at the origin, up 1 over 1 dot, up 1 over 1 dot, up 1 over, that's that perfect diagonal line. What about this guy, though? He is negative, so what does that mean he's going to be? Downhill. It has a negative slope. It is a negative slope, so he is going downhill. Negatives go downhill. And he still is the perfect slope of down 1 over 1, down 1 over 1, down 1 over 1. So this is down 1, right 1. He's the perfect downhill diagonal. And once again, if you're taking an OST test, you could open up Desmos and type in y equals -x. And you see that he's the downhill diagonal, right? Cool on the front? Yeah? Okay, let's go to the inside. You might want to have a couple colored pencils because we're going to do more than one transformation to most of these objects, so it's going to be easier if we do them in different colors. Remember, you want to be extra with your notes. Be extra. Saves yourself time later when you look over your stuff, if you're extra right now. Okay, so number 1 says, I want to reflect, and it says triangle. This is not a triangle, so let's change this shape to a some kind of quadrilateral. He's clearly not a, bless you. Got lots of typos in this baby. Not bad. Okay, so we're going to reflect this shape across the y-axis, and then we're going to reflect our new shape over the line y equals -1. Now here's the deal. You need to do stuff in the order that they say to do them. Many of these, if you do them in the wrong order, you get the wrong answer. There's hardly any of them that will be okay if you do them in any order you want. So whatever words they say, if I tell you to get dressed and then go to the store, you don't go to the store and then get dressed. That's how you get arrested. And then it's awkward, right? Like the last time you did that. Okay, so let's reflect A, B, C, D across the y-axis. So grab a color, any color you want. Let's color code. Okay, let's do this first step. I'm going to underline in pink because I'm going to do the first step in pink. Please draw me your line of reflection. Oliver, are you okay? Let's find the y-axis. Where's the y-axis? Okay, draw your line of reflection. This is my y-axis. I'm doing this one first. Laura, grab a paper outside of you there. Okay, I'm going to reflect over that line first. Okay, so here's the deal. We're going to do this by counting. We're going to do this by counting. Got it? We're going to use the whole idea that it is a bisector. This is bisecting. So the same distance from here to here, it's going to be backwards. Okay? Are you ready to count? Yes? Okay, which point do you want to do first? A. Okay, so tell me how far A is from the line. 1. So that means I need to go 1 on the other side and put a dot. So this is my A prime. It is a reflection over, so we're just going to do same distance. Okay, what about B? How many is that? 1, 2, 3, 4. So I got to do 4 to the other side. 1, 2, 3, 4, and put my dot. That is my B prime. D, how far is D? 1, 2, so I got to go 1, 2, and put my dot. That is my D prime. What about C? How many steps? 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. And so that is my C prime over here. And I'm going to go ahead and make my shape. Boing, 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 boing. I'm going to color him pink. And he should be a rigid motion, correct? Which means his size and shape should be exactly the same. Does it appear as though that's true? Yes. Please don't mess up your counting, because like I said, this is all counting. If you mess up counting, then your shape will look different, and you will know it looks different, and you will fix it before you move on. Correct? Okay, that is the first thing they tell you to do. I'm going to grab a new color, because it says then, so that means I do this next. Don't do it first, do it next. Then I reflect this prime shape over the line y equals -1. So is y equals -1 horizontal or vertical? Now the y-axis is vertical, but y equals -1 is horizontal. So go on the y-axis to -1. So go put a little note, be extra, on y-axis to -1. So that is right here. Remember, be extra in your notes. So we're going to go on the y-axis to -1, and it's going to be not the same way as the y-axis, because that would be dumb. It would be just drawing right on top of it. It is this line here. I'm doing this in a new color just so I see that I'm doing 2 transformations. So this right here is going to be my line of reflection. This is my line, y equals -1. So using the exact same idea, we're going to be counting our distance to this line. So which point do you want to do first? A? Sure. Okay, A prime. Here we go. That's 1, 2, 3, 4, 5. So I got to do 5 more on the other side, right? 1, 2, 3, 4, 5. That's going to put me way down here at the bottom. And this is going to be called my A double prime, right? My second. Okay, how far is D? 1, 2, 3 spaces. So go 3 more. 1, 2, 3. And that's going to be my D double prime. Are you doing your other ones? How far is C? 1, 2, 3. 1, 2, 3. That's my C double prime. How far is my B? 1, 2, 3, 4, 5, 6, 7, 8. Whoopsie. 5 and 5. Here he is. I'm going to color him and he should look same size and shape as everyone else, right? You see how all you're doing is counting. Just count distance away. You might want to color them in, especially if you got a bunch of hot mess going on your picture with your markings. And then we go back to the question to make sure that there was nothing to answer. So it just said reflect the shape across the y-axis and then reflect it across the line. It doesn't even ask us for any specific anything. Cool with that? Yeah? Okay, can I go to the next one? This one is an OST release question, and there's one like this on your test on Thursday. Do you know how to label your quadrants? Do you know who's 1, 2, 3, 4? Yeah. So this is what I think of. When I label my quadrants, I label them like I write a C. So start here, 1, 2, 3, 4. So exactly how I write the letter C, that's where I put my things. So draw an XY axis. So that means I'm starting where? How do you write the C? 1, 2, 3. And how do you do 4 in Roman numerals? IV, yeah. And yes, they are Roman numerals, so don't just put 1, 2, 3, 4. You never ever see 1, 2, 3, 4 like that. They're Roman numerals. And on the test, some people do this all right, and then they label their things 1, 2, 3, 4 wrong, and then they get the wrong answer. So just make sure you start off labeling them correctly. 1, 2, 3, 4. Okay, you got your pick? Yeah? You can walk around in the back. Walk and get a drink. Okay, so we're gonna we need a figure that's fully in quadrant 3. So what kind of figure you want to draw?
A rhombus.
A rhombus, sure. I don't care what you draw. A figure means you can draw a chicken if you want. In quadrant 3. So fully in means he's not overlapping any side. So here is my little rhombus that I'm drawing. Draw whatever you want. Okay, so he is fully in quadrant 3, right, Cece? I'm going to do this color first. It's reflected over the x-axis. So let's trace our x-axis. Where's that at? X-axis is here. Trace that. So you can see that you are folding him over that. So what quadrant will he end up in?
4.
X-axis. Fold over the, if you fold on the x-axis, where will,
The second one.
he'll be up in 2, upside down. So draw him up in 2, upside down. Same distance away, basically. He'll be upside down from whatever you drew the first time, correct? Okay, and then get a new color. Because it says then, that means you got to do it next. Don't do things out of order. Then you need to rotate 90 degrees clockwise. So that means you're taking this guy 90 degrees clockwise. Which way is clock? Okay, so we're going to go this way, 90 clockwise. And so he will be over here now, right? Whoopsie. Sorry, he's kind of ugly over there, but it doesn't matter. that all we have to do? And then answer the question. In which quadrant does the resulting image lie? How would we answer this? Quadrant 1. He lands in quadrant 1. Questions on that? Beep, beep, beep. Okay, number 3. You have a line segment. What's a line segment?
A segment of a line.
Part of a line has 2 endpoints. Yep. A line segment has endpoints at P and Q. Okay, so let's go ahead and draw him first. Now this is just like the graph paper you get on OST. There's no XY axis on it, so let's just go throw an XY axis on it. Just eyeball the middle-ish. Don't be that weirdo who sits there and counts all the boxes. But do try to stay on the line when you make your XY axis. Go, draw your XY axis. Just eyeball it. Okay, we need to put those points on our graph. So let's get those points on the graph so we can draw our segments. So where is -5, 1? Left 1, 2, 3, 4, 5, and up 1. I'm going to label him P. Q is where? Left 2, up 1. No, left 2, down 1, 2, 3. This is my Q, right? And this is a segment, correct? So you need to connect them. Okay, everyone sees my green segment. And once again, if you plot your points wrong in the very first step, everything after that is going to be messed up. So double check points all the time. If you're taking an OST test, you can just type these points in and you can see exactly where they are to make sure that you did not go the wrong way if you're checking your work. Okay, here's my segment. What are we going to do? I'm going to get a new color because I don't want it to be green. I'm going to go gray. Is reflected across the line y equals -x. What does y equals negative x look like? Yeah, what do you see right there? You see a negative. What's that tell you right off the bat? When you see the negative, you might want to just write downhill, right? So you remember to make him go downhill. So start at your origin and go downhill. Here's my origin, right? That is the perfect down 1 over 1, down 1 over 1, down 1 over 1. So do me a favor, put a dot there. Down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. Same thing backwards. If you make your line be off, it's going to be really hard because we're going to be counting. So start at your origin and make him perfect. Bless you. After you get your dots, go ahead and connect as best you can. You know that you always have your ID on your person, which is an excellent straight edge, right? So you don't need a ruler. You can just use your ID, right? Everyone got the line? Yeah? Okay. Remember, Josiah, remember how I told you to never count diagonal bubbles? I lied. Actually, when I told you that, I said there's only one time we will count diagonals, and now is when we'll do it. And the only reason is this, right? We are counting towards a diagonal line of reflection. So in order to get straight to it, we're going to have to count diagonal boxes. They're not officially bubbles, though, because you can't really bubble diagonals. That's weird. So that's why I do kind of like the dashes. Okay, so ready? Here we go. So that means, let's look at P. Put your pen on P. How many diagonal boxes? 1, 2. Do you see how that's 2 diagonal boxes? That means we got to go 2 on the other side to get the same distance away. So since that was 2 whole boxes, we go 2 whole boxes and put our dots. And that is our P prime. So we are counting diagonal boxes because our line is diagonal. That's the only reason. Okay, let's look at Q. How many diagonal boxes is Q? 1, 2, and a half. 2.5. We're allowed to have half boxes on diagonals. So that means on the other side, we need to go 2.5. So here's the half, right? Because we're kind of working backwards. And then here's our 1 and 2. And that puts our Q prime out there. And I'm going to draw my segment in purple so I see it. So does he appear as though he's congruent? Like a mirror image? In other words, if I were to fold this paper on the gray line, would they touch each other? Yes. Okay, so let's put a note on here that we're counting diagonal boxes only because the line of reflection is diagonal. So let's put a little note. Count diagonal because y equals negative x is diagonal. So we're only counting diagonal because the line is diagonal. Okay, you got a note for yourself? Count diagonal because the line is diagonal. But I think we still need to answer the question though. Because it says, what are the coordinates of the endpoints after the reflection? So we need to write down what P prime is and Q prime. Okay, what are the coordinates of P prime? -1, 5. So -1, 5. And what are the coordinates of Q? 3, 2, 3, 2. And that's the answer to our question. Cool? Got it? Okay. Just look at number 4. So, Talisha reflects a triangle FGH. Look at the picture. Is FGH there? No. She reflects FGH over the line y equals x to get the image shown. So this is her resulting image. But it doesn't matter because we can just reflect backwards to get her image FGH, or her triangle FGH. Okay, so she names the image ABC, which you see right there. Draw the pre-image and then list the coordinates. Okay, so where are we reflecting? Over what? The line y equals x. Okay, what kind of line is this? Y equals x. It's diagonal, uphill, diagonal. Uphill. It has a positive slope, so he is going uphill. Diagonal and uphill, which means we're probably going to be counting diagonal boxes, right? Okay, so let's go ahead and sketch that line. He starts at the origin, correct? And what does he do? What's his slope? Down 1 over 1, down 1 over 1, down 1 over 1. So make your dots on the perfect diagonal. Boom, 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 boom. Make them up backwards. Remember, if you're sloppy, it's easy to count sloppy blocks, right? What? Uphill. Undo, undo. It's uphill. Is mine going uphill? We need uphill, uphill. My bad. Uphill. I'm saying uphill and I'm drawing downhill. Uphill, uphill. So sorry, he's up 1 over 1. Sorry. We just did the downhill one. Sorry, new color. Good thing we're only doing one thing on this one. That's all right. Just get a different color. Okay, he's uphill. Thank you. Okay, you got him fixed? You got a new color uphill? Okay, so we gotta count diagonals. So we're gonna count diagonals. Count diagonals. Count diagonals. Okay, who do you want to count? Who do you want to do first?
G.
G? How do we know how to name these? Okay, this is what I do. I stack them. So you see how these look right here? Let's stack the F, G, H on top of the A, B, C, because she has to say them in the same order, which means the A and the F are matchy-matchy, and the G and the B are matchy-matchy, and the H and the C are matchy-matchy, okay? Because she named them like that, okay? So who do we want to move first? B? Okay, so how many diagonal boxes is B? So there's 1, 2, and a half, right? You got 2 and a half? So you gotta go 2 and a half to the other way. Here's my other half, and then 1, 2. So that means this point is his reflection, but what does she call B? She calls it G, because Talisha is special and she wants to call them other things besides primes. She's allowed. Okay, what about C? How far from the diagonal is he? How far is he? Is he 2 or 1? C is only 1 block away, right? So you need 1 block on the other side, 2 total. So C ends up here. But what does she call C? She calls it H. How far is A? How far is A? 1? Just 1? 2? 1 and a half. 1 and a half, right? So here's your half and 1. So that puts the reflection over here. And what does she call A? F. Okay, I'm going to draw that. Should be the exact same size and shape. Does it appear as though it's the exact same size and shape? Possibly. And then I got to answer these questions. I got to fill in these blanks. What are the coordinates of F and G and H? What? 1, -2. You guys agree? What's G? 0, 5. And what's H? 4, 2. And I think we can finish this next one. Let's go. This one's the easy one. Okay, let's crank this baby out. Don't pack away. Ready? Okay, so we're going to select all the transformations, all of them that will map onto itself. So that means land on itself, right? Map is landing on. So think about doing these things and what they're going to look like. Okay, the first one we're going to check. 180 rotation about the origin. So the origin is right here. What happens if I spin this 180 degrees? He's going to end up over here, right? So this is a no. And I'm going to do these all in different colors so you can see them. B, a 90-degree clockwise rotation about the point 4, 2. So find 4, 2. That's to the right 4 and up 2. That's right here. This is 4, 2. So that means if I stab down 4, 2 right here and spin it 90 degrees clockwise, will it land back on itself? No, he's going to be oblong down here. That one is not going to work. Okay, third one. Reflection across the segment MN. Where's MN? That's right here. Oh my gosh, that's the worst drawing ever. But if I were to fold this in half, would this work? No. Watch. Look at Q. That's 1, 2 diagonal boxes. 1, 2. Q prime would be up here. So if I folded this point would be up here. This would be like over here. It is not going to work. And they put these on there all the time. They don't work. D, reflection across PR. Where's PR? PR. PR. That's here. If I were to fold this across PR, this point is how many things away? It would probably land over here. So this one's probably going to work out, right? So let's put that one. He's probably going to work out. Reflection across the line y equals 2. Where's y equals 2? I go on my y-axis to 2. I draw my line. Is it going to work?
Yeah.
Nuh-uh. Because this point is going to end up where? That's 1, 2, 3, 4. 1, 2, 3. It's going to end up here. It is not going to work. The last one, reflection across QS. Where's QS? That's this one? Is that one going to work? Yeah, because this point and this point will fold over to each other. So this is a no, and this is a yes. Tuck him into page 36 if you don't have time to glue. We can glue tomorrow.